please.
Yeah, hi everyone. Happy to be here. Thanks for the invite. For those of you who have not met me previously, my name is Ismail. I'm a PhD student at the University of Bern and the University of Basel, and my research field concerns itself with natural language processing on pre-modern documents. So I was invited here to talk a bit generally about my research, and I tried to make it a bit more specific about works with editions. I will just start the share. Not so used to working with Teams, so. Do you see the slides? Yeah, okay. Probably don't see me because of the lighting. I'm very sorry. It's too bright outside. Okay. You just tell me if something isn't visible because I cannot see your faces right now. Just see my own screen. So yeah, the question, the title I chose is how can machine learning benefit digital editions? And I hope to shed a little bit of light to this question today. So I will first start by introducing my personal work, my personal research, and then we'll talk a little bit more general about machine learning and what it can do. So the data I work with is the historical land records of the city of Basel. So this is a collection of documents which consists of about 200,000 of these, and 80,000 of those are in the time frame that my group and I are researching, 1400 to 1700. Each of these documents contains, whoop, is that something for me? Just someone waiting, okay. So each contains a source excerpt, basically. So a source excerpt about a property in the city of Basel. And so these are usually the types are documents about sales, about seizures of properties, dues being paid or not being paid, and sometimes legal sources. All of these documents were aggregated in the last 200 years. And I'm not going to talk much about how we digitize them, but we do have them in digital form with a pretty good character recognition rate. So we can work with them. So I can work with them with my methods. So my question basically is for my project, in what way can natural language processing using machine learning contribute to to enable easier access, a better and improved access to this corpus, and what new methods, what distant reading approaches, for example, can we enable for historians or also for linguists or sociologists on this corpus. And it's also about collecting experience, how such a workflow to digitize, how to enrich this data can be done, and what amount of work, for example, would be necessary for an individual project to do that, and what collections would it be useful for. So let's look at a specific document from this corpus. I translated it to English but I tried to stay as close as possible to the structure of the document as possible because the structure is very relevant to the methods we're using. So for example, here we have this person, the Waldbrecht Hüglin, who is a chaplain of the diocese, and he seizes in the name of the St. John's Fraternity this house of Gallus Bechner, which is located at a grain market, situated at the corner Hutgassen. And then we also have the reason why it was seized, because he missed to pay his dues. This Gallus Bechner, probably, presumably. Now, if we want to annotate data, if we want to enrich data, there's always a question, what kind of information are we interested in? And let's look first about, I would say, more or less the completeness of information contained in this document. So first, we have the central event. We have the seizure. We could anchor this in the text with the predicate seized. And then we, of course, also have the relevant entities in the text which act in this event. We have the Waldbrecht-Hüglin, who performs the seizure. We have the organization, St. John's Fraternity at Burg. And we have Gallus Bechner, who presumably is the one being losing his property. And then we have this house that is being seized. We have additional information about certain persons. We have, for example, the information that Gallus Bechner is a bagmaker. If we put this a little bit in a technical form, we can say Gallus Bechner is bagmaker. And we also have the information that Waldbrecht-Hüglin is a chaplain of the diocese, which is not only an additional information what his role or his job is, but also it is a relation between him and the diocese, which is an entity of its own. And we have a secondary event as well, not only the seizure, we also have this event of the missed use. And, whoops, sorry. And this event, again, has, of course, entities that are important to its role. We have the house, which yields the interest. We have the amount that is yielded, and we have the organization which profits from the interest. And finally, we also have topological information. So we know here where the house is, more or less, that it is at the grain market and the Hutgassen. We could even say that we want to also capture this information, that it is at the corner to the Hutgassen. And this can be very important information, very interesting information when one does not have a city map of this time to reconstruct, basically, at least in relative terms, how the houses were located to each other. So this is a lot of information. And now I want to quickly look at how annotation is currently usually done. I have here the first example, the St. Galler Missiven, which were just recently published. It's a very, very nice edition, in my opinion. And it uses what I would say is the most common type of annotation at the moment. My personal name for it is short and flat, and you will see why. So let's look at this person entity first. You have this Jakob Schellang, and it is the annotation. I call it short because his this attribute of him, that he is von Ravensburg, this additional information about him, is not part of the annotation of Jakob Schellang. Only his proper name is annotated. Instead, Ravensburg is annotated by itself, and there is no connection between the two entities annotated. It might be that in the database where these entities are linked to, maybe there is the relation being annotated, but not on the text. Now, if we look at the Urfriedebücher der Stadt Basel, this one goes a step further, and this is less common from what I've seen. You have these long extended tags which capture the whole mention syntactically. So we have this person, the Lorenzen, dem Scherer am Fischmarkt. So you have his proper name, you have his occupation, and then you also have the place either where he works or where he lives. That's not entirely clear. And so first, I call this, instead of short, I would call it extended or long tags. And then the second is Fischmarkt, actually. You can't see this in this picture, but Fischmarkt is annotated as well as a place. So the annotation system of the Urfriederbücher allows for tags to be nested in each other. This allows to capture more information and put it just immediately at least give a vague connection between the two tags. But still, for example, the job is not being annotated in the Wikibücher. So next, let's talk about what we can, what my proposal basically is, how we can capture more of this interesting information that we saw in this text. So the annotation framework I work with is called Benash, which I've developed at the University of Bern together with some colleagues from different projects. And the idea is basically to have a annotation system that can capture entity annotation, events, roles, and the relation between entities. And it should be general enough, but still allow a precision that it can be used by very different projects, no matter if you work with land records or if you work with criminal records, if you have diary entries or letters, it should be able to be used by anyone. And at the moment, it's only the historical land records, which our project, which uses it intensely. But there's multiple projects who are starting now their annotation as well in this framework. Basically, the idea is if we have multiple projects in pre-modern German which use this kind of annotation, we can use this data which is compatible to train more general annotation models, which then new projects that enter the scene that want to use machine learning to enrich their data can also use. But I'm going already a step ahead of myself. So let's look quickly at these three pillars of our Benash requirements. And as you can see, one of those is machine learning. So for machine learning, there's stuff that's very important, for example, consistency. And consistency, for example, is just not really possible with short and flat tags. That's something I have seen in some of the bigger projects as well, some of those which are actually projects that put a lot of work into their annotation, but because they are using the short and flat system, they just fail to annotate their data in a completely consistent way. And then, of course, compatibility. So if we have one framework that is really transparent and open to everyone, we can ensure that we have this compatibility, which then in turn enables us to reuse data again and again. So let's look at how a person mention would be annotated in the Benash system. For example, if we have this Jakob Schellang von Ravensburg, this would be, the whole span would be annotated as a person reference. Then we would mark Jakob Schellang as the so-called head, so the core of this mention, basically. We would say that Ravensburg, of course, is a place, a location, and we would put a so-called so located at relation von Ravensburg to connect both of those and make clear what their relationship is. If we have the other example, Lorenzen dem Scherer am Fischmarkt, it's very similar, just with another tag, a so-called attribute. So basically this describes Lorenzen a little bit closer. And we also can make it more precise what kind of attribute it is. In this case, Ock stands for occupation. So it describes his job. He is a Scherer. And then we also have here again a head element. And this is how a annotated document looks in Benash. This is now again the German version, of course. The platform you see here, this is a screenshot in the platform Inception, which we use. It's a really good annotation platform, which also allows nested tagging. Now, you see this and you're probably like, well, this is a lot of work. This is much more than putting down short tags and flat tags. And you're completely correct. I'm not going to dispute that. But of course, so on one hand, we have a lot more information captured. This is one advantage of this. On the other hand, because we use this system, which is really consistent and complete, we have a much easier time training machine learning systems on this data. And I'm going to show you now, again, this document in Inception. And this is the document tagged by our model. So this is no human involved. This is just the model. There's some stuff missing because the model doesn't do relations outside nested tags yet, and it also doesn't do event annotation yet. But you can see here that the entity annotation is actually really, really good. I believe there's only, at least if I didn't miss anything, there's only one error here, which is this ek, which is mistakenly identified as a named location. But everything else, it does correctly. And this is our experience at the moment. We are now, the documents we are now tagging, we are always pre-tagging with the recommender with our machine learning model. So and you can imagine, of course, if we have a document like this, if we only need to fix a little error and everything else is already correct, we can spend much less time annotating the easy stuff and just focus on the more complex questions. This is now a bit of an easier document, so there's almost nothing really here which would take up much time. So this already works really well for our project. I I talked a lot about machine learning already, but just in case you have really never heard about machine learning, I'm just gonna go over some of the basics here. So if you want to train a model which can annotate entities, for example, you need basically two big things. You need a lot of raw data, just raw, especially from the language, basically, that your corpus consists of. With pre-modern data, of course, we always have this problem that it is hard to collect even just this raw data. With the embedding that we are using, Flare, we have made really good experiences, even with small corpora. In our case now, the historical land records of Basel seem to be large enough that there's almost no benefit of using what I call secondary raw data from basically from other pre-modern German corpora, just because we have so much ourselves. And adding the secondary raw data just introduces noise, just introduces language that is not actually seen in our corpus. Then the second big part is you will need annotated documents. And with the raw data, you train a language model, basically a model that holds all the information about how the language works. And then together with the annotated corpora, you can train a named entity model, which can then be used to do tagging like this. Yeah. Now, how much work does one have to put into it? In our case, for the historical land records of the city of Basel, we have annotated a little over 700 documents. So the model you just saw uses about that amount. The language model is, of course, trained over the whole corpus, over the whole of the 80,000 documents. And what remains to be seen is basically how much documents other projects need to create to be able to take our model and just fine tune it to their needs. So this probably depends a lot about how distant your data is from ours. So for example, if I let our model run, just now our model created from the historical land records of Basel, if I let it run on the Urfede-Bücher of the city of Basel, this is just anecdotally. I have not have evaluated it quantitatively. But I can see there that, for example, person mentions and organizations are recognized pretty well, which is not too surprising because both come from Basel from the same time frame. If I use it on data from Vienna, which are also land records, so on historical land records from Vienna that I have access to, I see for some certain tags, I see a very good performance. For example, persons are very well recognized. But for other tags, it's much worse. which is also not too surprising. The errors are very much in line what I would expect from the fact that our model has never seen Austrian language and has never seen Austrian documents. But it is actually performing still better than well, this takes I would have to go explain a lot to actually make this comparison. Yeah, it still performs surprisingly well, and we are now on course to have the project in Vienna create a test corpus for fine-tuning, where we will then evaluate how easily they can use our model to fit to their needs, and then use it to annotate their thousands of documents. And as you can already see on the slide, one point I just want to talk about too, because these numbers seem pretty low if you know the numbers for modern languages, is that errors are of course not all equal. Some errors are worse than others. And one thing I want to emphasize, especially to this community who makes the additions and would use such a model to create the annotations, is you have to know what the model is good at and what it is bad at. For example, for our model, I could say for our data, it is really good at recognizing jobs and persons. It is also really good at recognizing organizations. It is not so good still to really recognize all the house mentions. This is much harder to do. As you can see, the probability is a little bit lower. The score is a little bit lower for locations. And I would really recommend everyone using such a model to do a deep dive into how the tags are actually set. Of course, this is only necessary if you don't plan to correct the automatically annotated documents afterwards. If you do that anyways, good on you. So to bring it back to the last to the question, who should use it, who should do it? I think, of course, you should really consider it if you have a lot of lots of documents. In our case, with 80,000, there's really no question. You can either do, I don't know, a 10, 20-year project to go through that data and extract information, or you can do it in 1 year and machine learning. Then, of course, consistent structure and language. The more consistent your documents are, the better they will work. For example, in our case, with our land records, these are very formulaic. So the machine learning system has a very easy time to detect patterns and learn them. Then you have the question of repeating events. So again, this is something that's very good when you have, which you will probably have if you have pragmatic writing. So for example, in our case, basically most of our documents are either sales, seizures, or dues, like 80%. And so the system, when trying to learn events, can see the same event just with different persons and different organizations, and maybe sometimes a little bit different sentence structures again and again and again. If you now work for, let's say, a diary, this is going to be much harder, of course, because there's much more different events in those. And finally, of course, that's the point I already talked about before. If you have an addition project where you are willing to publish data that is not perfect, it is probably much more attractive to use machine-generated data instead of having everything human done. And of course, even if you strive for perfection, you can always take the machine annotated data and correct it. As I said, we are also using this model that I've shown as a recommendation module in our workflow. So finally, last words. If you don't have a lot of data, because some pre-modern corpora are pretty small, you can consider other options. So for example, a group in Berlin, for example, they are building a rule-based system for extraction of certain information. This works because they also have land records, which are very structured. But it is a lot of work. And I think this is really an option that has to be considered thoroughly. And then finally, we have not a lot of data and inconsistent, such as a diary. Your best way is likely to just go for large language models. I'm not a huge fan of those myself. And for information extraction, they are likely beaten by the traditional deep neural networks, like the ones I have shown here. But yeah, if you cannot create training data, these might be your best bet. On the other hand, of course, maybe you might do better with a more general pre-modern model, those which we are trying to develop right now. So that's it from me. Thanks for listening. I hope I'm in time, and I'm excited to hear your questions and comments.